Hello, everyone, and welcome to another episode of the Day 1 to Deep Tech podcast series, where we explore the people, technologies, and real world stories behind today's most exciting engineering careers. Today's conversation is about industrial automation, industrial IoT, and embedded systems, technologies that quietly power modern factories, manufacturing plants, warehouses, energy systems, and countless products we use every day. Many people have heard terms like PLCs, sensors, embedded systems, Industry 4.0, SCADA, industrial IoT, and smart factories. But how do these technologies actually come together? Why are industries around the world investing so heavily in automation? And what kinds of careers can someone build in this space? To answer these questions, we are joined by someone who has lived this journey firsthand, an entrepreneur who has built automation solutions, worked closely with manufacturers, solved real engineering challenges, and now leads an industrial automation startup. Thank you so much for joining us today.
Thank you for inviting me. I'm genuinely excited to be here because industrial automation is one of those fields that most people interact with every day without even realizing it. Every packaged food item, every medicine, every car, every electronic device, and even the electricity reaching our homes has likely passed through automated systems. Yet very few people understand the engineering that makes all of this possible. My hope is that by the end of today's conversation, listeners won't just understand what industrial automation is, they'll also understand why it's such a rewarding field to build a career in.
That's a wonderful place to begin. Let's go back to the beginning of your journey. Was industrial automation always your dream career?
Not at all. Like many engineering graduates, I knew I enjoyed solving problems, but I didn't know which industry suited me best. During college, I imagined I'd become a software developer because that seemed like the obvious path. Most of my friends were preparing for programming interviews, learning web development, or talking about app development. Industrial automation wasn't something we discussed often. In fact, I barely understood what happened inside a manufacturing plant. Everything changed during an industrial visit. Walking through a factory, I noticed huge machines moving with incredible precision. Conveyor belts carried products from one station to another. Robotic arms performed repetitive tasks without getting tired. Large display screens showed production data in real time, while engineers monitored everything from a control room. I remember asking one simple question: who's controlling all these machines? That question completely changed my career.
That's fascinating because many people imagine factories as places where workers manually operate every machine. But modern manufacturing looks very different, doesn't it?
Completely different. When people hear the word factory, they often picture rows of workers assembling products by hand. Today's factories are far more intelligent. Machines constantly communicate with one another. Sensors continuously collect information about temperature, pressure, speed, vibration, and product quality. Controllers make decisions in milliseconds. Software monitors every stage of production. Human engineers are still essential, but instead of manually performing every task, they're designing, monitoring, improving, and maintaining automated systems. That realization completely changed how I viewed engineering.
What happened after that visit?
I became curious. Instead of simply memorizing concepts for exams, I started asking practical questions. How does a machine know when to stop? How does a conveyor belt know when a product arrives? How can hundreds of motors work together without collisions? How does a factory detect a fault before a machine breaks down? Every answer led me deeper into industrial automation. I learned that behind every automated machine are embedded electronics, sensors, controllers, communication systems, and carefully written software. No single technology works alone. Everything works together.
Was your first job in automation?
Yes, although it wasn't glamorous, I joined as a junior automation engineer. Most people imagine engineering as writing brilliant code all day. The reality was quite different. Some days I spent hours tracing cables, some days I checked sensor wiring, sometimes I debugged machines that had stopped because of something as simple as a loose connector. Other days, I worked with senior engineers who could identify problems simply by listening to the sound of a motor. That experience taught me something important. Engineering isn't just about knowing theories, it's about understanding systems.
You've spoken about entering industrial automation through curiosity, but today you're leading your own company. That transition fascinates me. Many engineers dream about building something of their own one day, but very few actually take that leap. What made you decide to leave a stable engineering career and start an industrial automation company?
Honestly, it wasn't because I woke up one morning and decided I'm going to become an entrepreneur. It happened gradually. For several years, I worked on automation projects for different manufacturers. Every factory looked different, different products, different machines, different teams. But I noticed something interesting. Many companies were struggling with very similar problems: unexpected machine downtime, lack of production visibility, difficulty collecting reliable data, manual reporting, energy wastage, quality inconsistencies. Sometimes they invested in expensive equipment but weren't using even half of its capabilities. I kept thinking, there has to be a smarter way.
So the business idea didn't begin with technology. It began with observing problems.
Exactly. I think that's one of the biggest lessons entrepreneurship taught me. People often fall in love with technology. Successful companies fall in love with solving problems. Automation isn't valuable because it uses sensors, PLCs, or embedded systems. It's valuable because it helps a business produce more, waste less, improve quality, and make people's work easier. That realization slowly changed my mindset. Instead of asking, what technology should we build? I started asking, what problem keeps factory managers awake at night?
Was leaving your job difficult?
Very. When you're employed, your responsibilities are mostly technical. When you start a company, everything becomes your responsibility: engineering, sales, finance, recruitment, customer support, product planning. Sometimes I would spend the morning debugging a controller and the afternoon explaining invoices to customers. It was challenging, but incredibly rewarding.
Looking back now, was it worth taking the risk?
Without a doubt. Not because entrepreneurship is easy, it's definitely not, but because it allows you to create solutions that directly improve how industries operate. Every successful installation reminds us that we've helped people work more safely, more efficiently, and with greater confidence. That's a wonderful feeling.
That's an interesting distinction. Can you explain what you mean by understanding systems?
Absolutely. Imagine baking a cake. Even if every ingredient is perfect, forgetting one small step can ruin the final result. Industrial automation works the same way. A sensor might be functioning perfectly. The controller might be programmed correctly. The communication network might be healthy. But if one cable is connected incorrectly, the entire production line can stop. That's why automation engineers don't think about individual components. They think about how every component interacts with every other component. This systems thinking mindset became one of the biggest lessons of my career.
Looking back now, what was your biggest misconception before entering the industry?
I believed automation would eventually replace engineers. Ironically, the opposite happened. As factories became more automated, they actually needed more skilled engineers. Someone has to design automation systems, someone has to integrate sensors, someone has to program controllers, someone has to analyze production data, someone has to maintain machines, someone has to improve efficiency. Automation doesn't eliminate engineering, it transforms engineering. Instead of performing repetitive work, engineers spend more time solving complex problems and building smarter systems.
That's reassuring for people wondering whether automation and AI will reduce career opportunities.
Exactly. Technology changes jobs, but it also creates entirely new ones. 20 years ago, very few companies were hiring industrial IoT engineers. Today, they're in demand across manufacturing, automotive, pharmaceuticals, food processing, logistics, energy, aerospace, consumer electronics, and many other industries. Factories are becoming smarter every year, which means engineers who understand automation, embedded systems, and connected devices will continue to play a critical role.
If you could travel back to your college days and meet your younger self, what would you say?
I'd tell myself not to chase technologies simply because they're popular. Instead, I'd focus on understanding fundamentals. Learn how sensors work, understand electronics, write simple programs, build small hardware projects, be curious about how machines make decisions. Because once you understand the fundamentals, learning advanced technologies becomes much easier. The tools may change over time, but strong engineering fundamentals stay valuable throughout your career.
That's a great message to begin our conversation. We've learned that industrial automation isn't just about machines. It's about solving real world problems using electronics, software, communication, and systems thinking. In the next segment, we'll answer the question many beginners have: what exactly is industrial automation and how do modern factories actually work? We'll explore how sensors, controllers, embedded systems, industrial IoT, and communication networks work together to create the intelligent factories shaping the future of manufacturing. Stay with us.